Welcome to Sleepy Scientist Stories. I'm so glad you're here. Whether you're wrapped in a blanket while the world outside settles into a quiet, or simply lying still beneath a slow-turning ceiling fan, this space was made for moments like this. A moment to breathe, a moment to wonder. Tonight we'll drift softly through one of the universe's gentler mysteries. A story where light doesn't rush and time forgets to hurry. It's not about answers. It's about resting inside the questions. If these calm explorations help you sleep easier, I'd be grateful if you gave this video a soft like or floated a quiet subscribe. It helps more dreamy minds find their way here. And if you'd like, tell me where you're listening from. Maybe it's midnight by a window full of stars. Maybe it's early morning and the sky is still blue with sleep. Wherever you are, you're part of this journey now. So take a deep, slow breath. Let your mind loosen. Let the night unfold. And when you're ready, we'll begin. You lie still and imagine motion. Not a walk or a drive, but something stranger, smoother, impossibly fast. You're not racing through roads or flying through clouds. You're slipping past the rules themselves. The world you know begins to blur. Trees lose their shape. The stars stretch thin. Your body stays soft and still, but something in your thoughts begins to accelerate. You wonder, what happened if you kept going? Not a little faster, but faster than anything you've ever known. Faster than sound. Faster than a rocket, faster even than light, or at least close to it. And here the story begins to change, because the closer you get to light speed, the more time begins to melt. Not metaphorically, not as an illusion, literally. Time bends, it stretches, it slows down for you, while the world you leave behind rushes on. Einstein showed us this, and though his equations are quiet and clean, the reality they describe is anything but ordinary. You don't just move through space, you move through time, and speed twists time into something soft, like fog around your fingers. To you, the journey feels normal, but to someone watching, you seem to be moving in slow motion, like a dream drifting through still water. This isn't just an idea. It's real. Astronauts aboard the International Space Station age slightly slower than people on Earth. The difference is tiny, but it's there. A few milliseconds after months in orbit, their clocks tick more slowly because they're moving fast, and that's a quiet truth written into the fabric of the universe. And that fabric, space and time together, isn't something rigid. It stretches, it folds, it listens to motion. The faster you go, the more the universe leans in and says, very gently, slow down. You imagine someone watching you as you accelerate. A friend left behind on Earth. To them, your watch ticks more slowly. Your voice lags, your story unfolds in slower frames, but from your view, everything feels normal. Your breath, your heartbeat, your thoughts, they move in rhythm, just as always. It's only when you return, when you come back from the edges of speed, that the truth shows itself. You've barely aged, but they have. Days for them, maybe years, maybe lifetimes. You've become a traveller in time, not by building a machine, but simply by moving fast enough to let the laws of physics open their quiet doors. And yet there is a limit. No matter how much energy you pour into your speed, you can never reach the speed of light. It stays just ahead, always out of reach. The closer you get, the more resistance you feel, not from friction, but from reality itself. Your mass increases, time slows more and more, but light remains ahead, a guide you can follow but never touch. Because light doesn't just move fast, it moves in a way no other object can. From your perspective, time flows. It has a direction, a rhythm. But for a photon, a particle of light, time does not pass at all. From the moment it's created to the moment it's absorbed, it experiences no time. It is born and it arrives in the same instant. A photon might leave the heart of a star and travel for 10 billion years before reaching your eye. But to the photon, that journey took no time at all. It did not experience travel. It simply was. This timeless motion tells us something profound. Light is not just fast, it is timeless, and because of this, it defines the structure of reality. It's the ruler by which all other speeds are measured. It keeps cause and effect in line. It prevents paradoxes. It ties the past to the present, and the present to the future. Without light, time could unravel. Stories wouldn't make sense. Memories couldn't form, the arrow of time would drift, but light holds everything together, silently, gently. You begin to see light differently now, not just as brightness or colour, but as a quiet framework, a thread that stitches reality into coherence, touches everything, not by force, but by presence. And the laws it follows are not chaotic or harsh. They are steady, elegant, and soft in their persistence. A photon travels not because it wants to, but because it must. It carries energy, it carries time, it carries the very rhythm of existence. You wonder, wonder, then if you were somehow to become a beam of light, what would the world look like? Would everything stop? Would the universe collapse into a single frame? It's not a question of imagination alone. It's a question Einstein himself once asked. As a teenager, he pictured himself riding a beam of light, racing alongside it, and what he saw, what he dreamed, led him to transform physics forever, because no matter how fast you move, light always moves away at the same speed. That consistency breaks open everything. It rewrites what space and time even mean. So now you return to stillness, and you understand that it's not truly still. Even here, in rest, you are moving. You spin with the Earth. You orbit the sun. You drift with the galaxy through space. And all the while, time ticks forward in your frame. But you know, softly now, that this ticking is not absolute. It bends with speed. It bends with gravity. It listens to light. And you, small, thoughtful, drifting into sleep, a part of that dance, a part that feels, a part that wonders, and above you, somewhere in the dark, a photon leaves a star. It begins its journey through the vast quiet. It doesn't know time, it doesn't know distance, but one day, perhaps tonight, it will arrive. Maybe it will brush your eyelid, maybe it will be absorbed by a telescope, or a flower petal, but wherever it lands, it will carry with it something soft and ancient, a message from the timeless heart of the universe. You imagine it now, with childlike stillness, the moment Einstein did the same. A boy, barely 15, standing under a sky too big for answers, wondering not what a star is made of, but what would happen if he could chase its light, not with a telescope or mathematics, just with his mind. That question, so simple and so quiet, shook the foundation of physics. It did not arrive with a noise, it arrived with wonder. And it still echoes. You close your eyes and imagine it. You are no longer standing still. You are moving not through the air, but through the very structure of the universe. Your speed increases, past sound, past rockets, past anything that exists in the world you know. You approach the speed of light, that cosmic limit, and suddenly everything begins to behave strangely. The scenery ahead doesn't rush toward you, it stretches. The stars lose their sharpness. The world ahead becomes a tunnel of frozen light, and the space behind you, forgetting. You are no longer seeing things happen in time. You are skimming the edge of time itself. Now ask yourself, if you were riding beside a beam of light, what would it look like? Would the wave freeze? Would the motion stop? That was Einstein's question. If light is always moving at the same speed, no matter who observes it, then what happens when the observer tries to match it? It doesn't behave like sound, which you can catch or cancel. Light resists. It insists on its speed no matter how fast you move. That unbreakable law, that constancy, tells us something strange must be true. Time and space must bend to protect it, and so they do. When you try to match light's speed, time stretches for you. Space contracts. Distances shorten. Durations lengthen. These aren't illusions, they are real consequences of the universe preserving light's sacred rule. You begin to realize you cannot see a frozen beam of light because no such thing can exist. Light must move. It cannot be at rest, and if you ever tried to become it, you would have to leave behind more than mass or momentum. You would have to leave behind time itself. Einstein didn't stop at the question. He kept going, and his thoughts grew sharper with the years. From this simple dream came the theory of special relativity, a framework that describes how time and space change depending on how fast you move. It's not a theory born from blackboards, it's born from the imagination, and it tells us that everything, your heartbeat, your breath, your aging, depends on your motion through space. The faster you go, the slower your time moves compared to others. Not because the clock is wrong, but because time itself listens to your speed. You picture a clock now, one that floats beside you as you race near light speed. To you, it ticks normally, but to someone watching you pass by, it ticks slowly. If you and that person met again, your histories would not match. You would be younger. Time would have moved more slowly for you. This is not a thought trick. It's been measured. Muons, tiny particles that decay in microseconds, live longer when they move fast. Not because they resist decay, but because time bends for them, just as it would bend for you. You begin to understand what Einstein must have felt. That awe when imagination touches reality. That something so strange, so poetic, could be written into the very fabric of nature. And still, this is only part of the dream, because even though you can get close to the speed of light, you can never reach it. Why? Because your mass increases, Your energy requirements grow infinite. The closer you come, the more the universe resists. Light is not a goal to reach. It's a boundary that holds the world together, a messenger that moves but never waits, always in motion, never changing speed, never aging. And from the beam's perspective, there is no time, no before, no after. A photon is born, travels billions of years, and arrives, but it is in that dream that Einstein saw the truth, that time is not the same for all, that space is not flat and fixed, that speed and light and time are interwoven in a dance too soft to see, but too powerful to ignore. As you drift towards sleep, you realize you've been chasing light not just to understand physics, but to feel something deeper, to imagine a world where motion bends the rules, where questions create equations, where a teenager's thought could become the foundation of modern science. And in that there is something beautiful, something gentle. Einstein never caught the beam. He never had to. The dream was enough. And because of it, we now know that reality is more fluid, more delicate, more connected than we once believed. You may never fly at light speed. You may never float beside a photon. But tonight, in thought, you did. You followed curiosity into the silence of the universe. You listened to the laws that don't raise their voices. You wandered with Einstein, not to escape the world, but to see it more clearly. And in doing so, you found a kind of stillness, a place where time is no longer a straight road, but a soft terrain, shaped by speed, memory, and light. And in that stillness, maybe you can rest. Imagine a quiet room with two clocks. One stays still on a wooden table, it's ticking soft and even. The other is placed inside a sleek machine, built to move with precision, ready to glide faster and faster across the room. You watch both clocks start at the same moment, identical in rhythm, identical in design, but as one begins to move, carried away at high speed, a quiet shift begins to unfold. When the moving clock returns and you place it beside the one left behind, something feels different. You look again, the moving clock has tipped fewer times, time has passed more slowly for it. The two clocks no longer agree, and yet neither one was broken. You're not imagining this. It's one of the most profound discoveries of physics. Time is not absolute. It doesn't march forward at the same rate for everyone. When you move fast, especially near the speed of light, your time stretches. This isn't because the clock malfunctions. It's because the very fabric of time stretches with speed. Einstein called this time dilation, and it changes everything. The ticking of a clock is not immune to motion. It listens to how fast it's going. It keeps pace, not just with the mechanism inside, but with the universe around it. It's hard to believe at first, because in your everyday life, time feels solid. Seconds pass the same whether you're walking, running, or lying down, but the change is there. Tiny but real. GPS satellites floating above Earth must adjust their onboard clocks, because they tick faster than ours. Why? Because they're farther from Earth's gravity and moving at speed. Both motion and gravity bend time. Without correcting for these bends, your navigation would be lost. The map on your phone would point you in the wrong direction. Time, it turns out, is local, personal. Now imagine you're holding a perfect atomic clock, one of the most precise instruments we've ever built. You take it on a plane, flying high above the surface of the Earth. When you land and compare your travelling clock to the one that stayed home, you find a difference, not in design, not in wear, but in time itself. Your clock is behind. This was proven in the Hafaliki experiment in 1971. Time moved more slowly for the moving clock, and yet it wasn't broken. It had obeyed the deeper rules, the rules Einstein glimpsed when he first imagined chasing light. You think about what this means. Not just for machines, but for people. What if you were the one moving with the clock? You'd feel normal. You'd age normally. But when you return to your still twin, you'd be younger. Not by choice, not by magic, by motion. This is the heart of the twin paradox, a story that's not fiction, but physics. It tells us that the faster we move, the more gently time flows through us. A person in motion ages more slowly than a person at rest, even if both feel nothing strange. Time, like water, moves differently depending on how fast you wade through it, and yet nothing feels off while you move. Your heart still beats, your thoughts still wander, your dreams still come and go. Everything in your frame feels normal because your sense of time bends with you. You and your clock both stretch together. It's only when you compare across frames, yours and the still world you left behind, that the difference appears. You've experienced fewer moments. A moving clock proves it. Time does not flow as one great river. It flows as many, each curved and folded by speed and gravity. The deeper you go, the stranger it becomes. You imagine not just travelling with a clock, but becoming the clock yourself. Every cell in your body ticking with its own rhythm. As you move faster, your metabolism slows. Your processes stretch. You live longer. but only relative to those you leave behind. You haven't gained time, you've simply stepped outside the pace of others. This too has been tested, not with humans, but with particles like muons that rain down from space. These particles should vanish in microseconds, yet when they move fast through the atmosphere, they live longer, not because they resist decay, but because time itself gives them more room. And if time can stretch with speed, can space bend with light? What happens when gravity touches light's path and space itself curves? Perhaps the next question lies not in clocks, but in the light that bends around stars. You follow time as it stretches softly with motion, watched clocks tick differently depending on how you move, but now you begin to sense something even stranger, that space too is not still. It bends, it curves, it flows in the presence of mass, and light listens to that curve. You imagine yourself in deep space, far from planets and stars, floating in silence. There, a beam of light moves straight, as if nothing in the universe could ever disturb its path. But bring a star close, and something subtle happens. The light bends, not because it wants to, not because it slows down, but because the space it moves through is no longer flat. You don't notice this bending in everyday life. The sun's light feels warm, steady, and unwavering. But in 1919, during a total solar eclipse, scientists measured the position of stars behind the sun, and something miraculous happened. The stars appeared slightly shifted, as if the sun had pulled their light into a curved path. It wasn't the starlight that changed, but the space around the sun. Light was still moving in a straight line, only now space itself was curved. This is the quiet brilliance of general relativity. Mass doesn't pull on light directly, it shapes the space through which light moves, and the light obeys. You imagine space not as a cold grid, but as a soft, flexible fabric. Place a heavy ball, like the sun, onto that fabric, and it dips. Now roll a marble, like a beam of starlight, near the curve, and it follows the bend. It doesn't think, it simply moves along the shape of space itself. This is how gravity works in Einstein's view, not as a force that tugs, but as a presence that reshapes geometry. Every planet, every star, even you, leave gentle dents in this cosmic fabric, and wherever space curves, time does too. This bending of light has a name: gravitational lensing. When light from a distant galaxy passes near a massive object like a black hole or a cluster of galaxies, it curves. Sometimes it even splits, showing us multiple images of the same object. These lensed galaxies are not tricks of the eye. They are the universe showing you how shape and motion come together. It's not just beautiful, it's informative. By watching how light bends, we learn how much must be hiding where we can't see. Gravity becomes a lens, and space becomes readable through its curves. Now you think of something deeper. Light has no mass, and yet it bends. How is that possible? It's because in Einstein's universe, mass tells space how to curve, and space tells light how to move. Light isn't immune to gravity, because gravity isn't just a pull, it's a reshaping of the stage on which all things play. Even massless particles must follow the curves written into space, and so even the swiftest thing, light itself, must bow to gravity's silent architecture. Imagine standing on Earth, looking upward. Light from stars thousands of years away has bent slightly on its way to your eyes. You are never seeing things in perfectly straight lines. Every glimmer is slightly altered, but it's not distortion, it's clarity of a different kind. You are seeing the shape of space itself, traced by light like ink on invisible paper. Each photon tells a story about the path it took and the mass it passed. You are watching the memory of space, not just its surface. And what does this mean for time? Because time and space are one. When space bends, so does time. A clock near a massive object ticks more slowly than one far away. On Earth, time ticks slightly slower at sea level than it does on a mountain peak. It's almost too subtle to notice, but real enough that your GPS would be wrong without adjusting for it. This bending of time and space is not fantasy, it's everyday physics, and you live inside it constantly. Now imagine something heavier, a neutron star, a black hole. The space around it bends so sharply that even light may spiral inward, caught not by a wall, but by the steepness of the curve. Light doesn't stop, it just can't escape. This is the event horizon, not a place where something happens, but a boundary where space tilts so far inward that every path leads back. Even time bends inward there, and from the outside, light trying to leave slows, stretches, fades. What was once bright becomes a whisper, but you don't need to fall into a black hole to feel this. The principle is everywhere. Light that climbs out of gravity's well loses energy. It redshifts, stretching into longer wavelengths. This is gravitational redshift, the slowing of light's frequency as it escapes a curved space. And yet the light still travels, still reaches, still tells its tale. Each photon that enters your eye tonight carries the memory of curves it crossed, the time it passed through, the space it honored. You begin to feel it. This is not just a lesson in theory. It's a way of seeing. You are surrounded by a universe that moves gently, that bends with presence, that honors the quiet structure of reality. Light is not just how you see, it is how you understand. It reveals not only surfaces but shapes, not only direction but history. And in its motion, silent, straight but curved, you begin to witness the dialogue between mass and movement, between energy and the emptiness that holds it. Even here, in stillness, you are part of that dialogue. Your body presses softly into the earth. The earth curves space around it. Light responds, time adjusts, and everything you are, every second you feel, arises from this silent dance. The star bends light, that bends space, that bends time, that bends you, and still, the universe remains quiet. Nothing shouts, everything whispers. But if space can bend and light can follow that curve, what happens when the traveller returns? What if two people live different time stories, one still, one in motion, and met again? What would they find waiting in the gap between their clocks? You imagine two twins born beneath the same sky, hearts beating in rhythm, growing together like reflections. They share time, the same birthdays, the same clocks, the same slow unfolding of years, but then one leaves. Not emotionally, not metaphorically, physically. The ship is built, sleek and silent, ready to travel near the speed of light. One twin climbs aboard, the other stays behind, and from that moment their story begins to stretch. Not in memory, not in feeling, but in time itself. This is the twin paradox. And though it sounds like science fiction, it's a quiet truth of motion, written into the rules of space and time. You follow the travelling twin into space, where stars drift by like distant lanterns. The ship moves faster, ever closer to light speed. Inside, the traveller feels nothing strange. Meals are eaten, books are read, sleep comes and goes, but from Earth, something subtle is unfolding. The twin who stayed behind watches the calendar turn faster than it does on the ship. Months pass, then years, then decades, and when the traveller returns, something astonishing has happened. They step out of the ship with the same soft eyes, the same calm breath, the same youth, but their twin, the one who stayed, has aged. This isn't a trick or a misunderstanding. It's the result of time dilation. When you move near the speed of light, time passes more slowly for you than for someone at rest. To the traveller, the journey felt short, maybe a few years, but to the twin on Earth, far more time has passed. This is not a failure of clocks. It is the nature of time itself. The faster you move, the more gently time touches you. And when you meet someone who has stayed behind, you find their days have piled higher than yours. You pause and feel the strangeness of it. Two people, born together, shaped by the same moments, now separated not by distance, but by time's unequal rhythm. It's not a matter of perception. It's measurable, proven, and yet it feels deeply human, like a story of return and loss written in physics instead of poetry. The one who travelled is younger, not because of magic, not because they missed something, but because motion reshaped their time. You wonder, how can this be fair? Why doesn't the travelling twin see the Earth twin as aging more slowly? Why doesn't the paradox cut both ways? And here lies the subtle key. Symmetry is broken. The traveller turns around, they accelerate, they change direction, and in doing so they shift frames. The twin on Earth remains in a single steady frame of reference, while the traveller leaves one, enters another, and returns. That change, the break in uniform motion, makes all the difference. Time doesn't punish movement, it simply listens to how it's done. You realise then that this is not just about twins or rockets. It's about how the universe measures experience, about how even two people with identical genes, identical beginnings, can live different spans because of the paths they take through space. Every second you feel is shaped by where you are and how you move. Time is personal, local, not just ticking on some distant cosmic metronome, but unfolding uniquely for every observer. There is no master clock, only clocks that agree when they stand still beside each other and drift apart when they move. Now, imagine being the twin who stayed. You've watched the seasons come and go. You've aged. Your face has changed. But your sibling, the one you waved goodbye to long ago, returns looking just as they did when they left. It's not just a reunion, it's a reminder that time is not shared equally. You've waited, you've lived, and yet to them only a short time has passed. You reach out, and for a moment the gap between your ages is not measured in years, but in velocity. You begin to understand that this paradox, this elegant twist, is more than a curiosity. It reveals how deeply woven time is with space, how motion sculpts experience, and how the same journey can mean different things depending on how you move through it. The travelling twin didn't skip time, they simply walked a different path through space-time, one that bent their minutes wider, one that touched their heartbeat more slowly, one that gave them a quieter kind of aging. You picture the two of them now, reunited, side by side, one wrinkled, one smooth-faced, one with memories that stretch across years, the other with memories that blink by like dreams. They sit quietly, trying to match timelines, to tell stories, to find shared places, and though they live differently, they are still bound by the wonder of their reunion. And this science, strange as it seems, is not isolated in rockets or theories. It's reflected in the particles around you, in the muons from cosmic rays that live longer when they fall through Earth's sky, in the satellites orbiting overhead that must adjust for time's flow to guide your map correctly. The twin paradox lives in your world, not just in dreams of space, but in every system that obeys the quiet curvature of relativity. You close your eyes and imagine yourself as both twins at once. One is standing still, one is flying through space. One feels time as a river, one feels it as a pool. And when they meet, they touch hands not just across years, but across understanding. They are both right, they are both true, and the paradox dissolves into harmony. Not contradiction, but complexity. And so, as you breathe slowly tonight, you feel it too, that time is not one thing, it is many. It stretches with motion, it listens to your journey, and sometimes, when the journey ends, it brings you back not just to a place, but to a person who has waited, a person who has aged, a person who remembers. And in that moment, time bends softly between you, like light around a star. But what if you kept going? Faster, closer to light itself? What happens when you approach the very edge of what the universe allows? Does time stop completely, or just whisper more slowly? You begin to move again, not slowly this time, but with purpose, with speed. A different kind of stillness fills you, one that grows not from rest, but from acceleration. You feel the universe resist, not with force, but with geometry. As your imagined spacecraft approaches the speed of light, the familiar becomes strange. Time stretches and distance shrinks, and energy gathers around you like heat from a silent star. You are not moving through space. Space is tightening around your motion. The faster you go, the harder it becomes to go faster still. This isn't friction or machinery. It's built into the laws of nature. Your mass increases, not in a way you can see, but in a way the equations insist upon. Every bit of extra speed costs more and more energy, until even the engines of imagination begin to falter. You are pressing up against the universe's unbreakable limit, the speed of light. Not a speed chosen at random, but the fastest anything can go. Not just a ceiling, a boundary that defines how space, time, and causality hold together. You wonder, what happens if you could reach it? What would the world look like from that edge? But the answer, softly, is this: you can't. Not because the universe is punishing, but because it is precise. If you could move at light speed, time would stop for you. Distance would vanish. The entire universe might shrink to a single line. But you aren't light. You have mass. You are bound to time, and time does not vanish for you. It only slows, like a breath held just a little longer. The closer you get to light's pace, the more stretched your seconds become. This is the universe protecting itself from contradiction. If you could exceed light speed, you could break causality, arrive before you left, undo what's been done. That's not just confusing, it's dangerous. And so physics builds in a kind of graceful safeguard. The faster you moved, the more the rules fold around you. Time slows, energy rises, mass increases, until you reach a place not of motion, but of stillness within motion. You're going faster than ever, but your experience slows. The world outside rushes forward, while your inner time glides like a feather in fog. You think again of light, not just as a traveller, but as a marker. A photon doesn't experience time. It doesn't measure space in the way you do. From its perspective, it is emitted and absorbed in a single moment. For you, such a state is unreachable, but nearing that speed gives you a glimpse. It offers a hint of timelessness, a taste of how space and time stretch and fold when pushed to their limit. Now imagine watching someone from your ship, a friend back home, living their days, counting their hours. To you, their time is speeding up. You see them move through months, while your own watch ticks only minutes. Their world ages, while yours remains hushed. You could return one day, stepping off your ship to find the future waiting, a world older, change. You would be a time traveler, not by jumping, but by moving near the speed limit of light and letting time bend itself around your path. This bending is not reserved for fiction. It is measured, confirmed. In laboratories, particle accelerators take electrons and push them close to light speed. Their behavior changes, their lifespans stretch. They orbit and dance differently. The closer they move to the limit, the more nature adapts. And each time the equations hold true, they tell us something deep. The universe doesn't break, and in bending it reveals a more gentle, more astonishing kind of order. You look outside your ship now and the stars don't shine as they once did. Ahead their light has shifted, compressed into blues and violets, a relativistic Doppler effect. Behind you the glow fades to red. Space itself seems directional. Forward is dense and fast. Behind it's soft and stretched. This isn't a trick of sight, it's a transformation of perception. Your motion changes how the cosmos meets your eyes. Time dilation, length contraction, and the compression of light, all reminders that speed is not just movement, it's experience, sculpted by velocity. And you feel it, even in imagination, the nearing of a threshold that can never quite be crossed. The closer you get to light speed, the more it recedes like a horizon. You aren't slowed by obstacles, you are slowed by nature's design. By the way, the universe builds consistency into its bones. Light speed isn't a challenge to overcome, it's the scaffold of space and time, the frame that holds it all upright. And in approaching it, you aren't defying the universe, you're learning how carefully it's made. You ask, is there anything that can go faster? Anything that can break through? Some theories whisper of particles called tachyons, which always move faster than light, but they remain in the realm of speculation. No one has seen one. No equation demands their existence. For now, perhaps forever, light remains the fastest signal, the fastest story. It moves not just through space, but across everything that allows space to exist. You rest your hand on the window of your imagined ship and feel nothing. No wind, no shaking, only the quiet hum of speed and the silence of distance. That out here there is no friction. No road. Out here there is no friction. No road, no resistance except that which space-time itself imposes. And even that resistance is not a wall. It's a gentle curve holding the pieces of reality together. Every law, every force, every form of matter listens to this limit. And every dream of faster travel must first understand what it means to approach, but never reach, this sacred boundary. So you slow now, not because you must, but because you can. You return from the edge of light's domain, bringing back more than velocity. You bring understanding. That speed is not just power, it's perspective. That motion changes what you are, not just where you are. And that in the soft bending of time and space near light speed, the universe doesn't become chaotic. It becomes deeper, more ordered. Now that you've met the limit, now that you've felt time tremble, you begin to wonder, what if this speed, this boundary, isn't just a number? What if it's the reason everything holds together? What if light speed is the law that writes the universe? You've stood near the speed limit of the universe, where time slows and space folds. But now you look deeper, not just at what light does, but at what it defines. You begin to see that the speed of light is not just a number, it is a law, a rule that does not merely describe the universe, but one that builds it. It's the thread that stitches time to space, the pace that keeps causality in line. Without this rule, nothing would follow. Nothing would make sense. You wouldn't know what came first, you wouldn't know what could follow. The universe softly and entirely is shaped by how light moves. You imagine turning off all the stars. Every photon disappears. Darkness fills space, not with emptiness, but with silence. The silence of stopped information. Because light is not just brightness, it's how anything knows anything else. When an event happens far away, a star flares, a planet moves, a hand waves, you see, you feel, you experience only because light carries the message. It's not just illumination, it's communication. The speed of light sets the pace for how knowledge moves. And this matters because the speed of light is the fastest anything can carry information. No signal, no pulse, no particle can tell the universe something quicker than light does. This boundary, this constant, creates the structure of cause and effect. A cause must precede its effect. A spark must come before the flame. And light speed ensures that across all of space-time. Without it, events could unfold out of order. stories could unravel, but instead, light's pace preserves the shape of time, and time, in turn, protects reality. You realize now that light's speed isn't fast just by human standards. It's fast in a way that defines all speed. It's the ruler by which all motion is measured. Every velocity is a fraction of it, every journey is compared against it. It is woven into Maxwell's equations, into relativity, into the way energy and mass communicate. It is the C in Einstein's most famous equation. E equals mc2, not just a letter, but a bridge between the fabric of reality and the rhythm of energy. The C doesn't just sit there, it binds, and yet it's constant. Always 299,792 kilometers per second in a vacuum. It doesn't matter how fast you're moving, which direction you're going, or what you believe. Light speed never changes. This is not just surprising, it's revolutionary. When Einstein first proposed this constancy, it overturned the idea of fixed space and universal time, because if light speed is always the same, then something else must bend, and that something is space and time themselves. You imagine a universe where light moved differently in different directions, where its speed depended on how you chased it or watched it pass. That universe would be broken. There would be no agreement between observers. Physics would no longer be universal, and so it's not that light happens to move at this speed, it must. Its constancy makes the laws of nature consistent. It ensures that what's true here is true elsewhere, for everyone, at every moment. It is the common language of the cosmos. You're going faster than ever, but your experience slows. The world outside rushes forward, while your inner time glides like a feather in fog. Even the concept of simultaneity, of things happening at the same time, depends on light. In relativity, what one person sees as simultaneous, another might not. Two sparks, two waves, two handshakes may appear to happen together, until someone else sees them from a different frame. And what makes that difference? The speed of light. It's the delay between events, the boundary between moments. It shapes not just motion, but perception. You think about how even empty space obeys this law. Light travels fastest through a vacuum, slower through glass or water. But even then, the rule remains. It isn't light itself that slows, but the way it interacts with the medium. The fundamental limit, the maximum, never changes, even in the folds of gravity or the swell of a star. Light holds to its path. If anything else moves faster, it creates shock waves, like a sonic boom for light, but never outruns the rule. And you realize something deeper still, that light speed limits aren't limitations, they are permissions. They allow the universe to have order, they allow particles to interact predictably, they ensure that every equation written in physics works the same way across galaxies. Without this limit, atoms wouldn't hold, forces wouldn't balance, the very fabric of matter would lose its rhythm. Even in quantum theory, where probability reigns and uncertainty blurs the edges of reality, the speed of light remains sacred. Entangled particles may seem to act instantly across distances, but no usable signal ever travels faster than light. Quantum weirdness dances under the same ceiling. It doesn't break it, it obeys it in its own mysterious way. And that obedience keeps the universe coherent. You begin to feel comfortable in this, that something so universal, so constant, exists beneath all change. Planets drift, galaxies spin, time flows unevenly. But light moves with certainty. With quiet commitment, it waits for nothing. It changes for no one, and in doing so it offers a kind of peace that even in the most chaotic corners of space, the speed of light holds. Even in the first second of the Big Bang, when everything expanded in furious silence, light had a speed to move by, the law to carry with it. And so, you lie still, thinking of all the things light touches, the soft glow of a candle, the burst of a supernova, the signal that tells your phone where you are, the colour of a leaf, the beam that left a star 1 billion years ago and found your eye tonight. All of it is moving under the same rule. A rule not forced, not shouted, just followed. Because it is written not outside the universe, but within it. You understand now. The universe is not just a place filled with light. It is a place shaped by it. Not because light is special in itself, but because its speed defines the very blueprint of existence. And that speed, Gentle, exact, unwavering, allows space and time to hold hands and move forward. But if the speed of light gives structure to the universe, what happens when the universe itself begins to stretch? What if space expands, not with motion, but with time itself unfolding? Close your eyes and try to imagine stillness, the kind that feels like forever, the kind that seems woven into space itself. Fixed stars, quiet galaxies, a night sky that never changes. But that calm is an illusion. Even the deepest corners of space are in motion. Not the motion of objects moving through space, but of space itself unfolding, expanding, stretching softly between the stars. This isn't something you can see with your eyes. It's too slow, too vast, too gentle. But it's real. The universe is growing, not like a balloon filled with air, but like the very fabric of reality, gently lengthening, moment by moment. You float in your imagination now, far above galaxies and dust, looking down not on objects, but on the space between them. You see galaxies not speeding away from some center, but being carried like driftwood on a tide by the expansion of space. It's not that everything is racing outward on its own. It's that space itself is growing between everything. Two galaxies, once close, find themselves farther apart without ever having moved, like dots on a stretching sheet. They're still in the same place, but the place has changed. This expansion was first seen in the light of distant galaxies. Astronomers noticed something odd. The light reaching Earth from those galaxies was stretched toward red, not by chance, not by movement through space, but because the space the light travelled through had expanded. This is redshift, not like the Doppler shift of sound you hear as a car passes, but a stretching of the very wave itself. The light left blue, it arrived red, because space grew around it, like a whisper shouted across an ocean that grows wider as the sound crosses it. You begin to understand that expansion isn't a thing that happens somewhere else. It's not about movement through space. It's about space doing something new. The distances between galaxies grow, not because they're flying apart, but because space itself is swelling. Every second, every moment, the universe becomes larger, not into something, but into itself. It needs no edge, no outside. It simply expands because it can, and because it has since the beginning. You think of the Big Bang not as an explosion from a point, but as the sudden beginning of space and time themselves. Not a blast outward into emptiness, but the unfolding of space from within. Every point in space was once closed, and now every point moves away from every other. There is no center, no edge, no explosion, just expansion, soft, uniform, and ongoing. The galaxies are not debris from a blast, they are passengers on a stretching ocean, pulled apart not by force but by the quiet will of space. And what drives this stretching? For a long time we thought gravity would slow it down, that galaxies might eventually stop moving apart, that the universe might fall inward. But then came the discovery of dark energy, a gentle force woven into the vacuum itself, not a thing we can see, but something we can measure through its effects. It doesn't pull, it pushes, and instead of slowing the universe, it makes the expansion speed up. As if the universe is not just unfolding, but accelerating into openness. You try to feel it now, the quiet rushing of something too large to touch, the knowledge that between every galaxy more space is born. The night sky is deeper than it was yesterday. The light from distant stars takes longer and longer to reach you, not because of their distance alone, but because the road itself keeps growing. This isn't just about objects drifting, it's about the map itself stretching between them. And what does this mean for light? For time? A photon leaving a galaxy billions of years ago must travel not just across space, but through its expansion. Its journey is longer than its starting distance. Its path stretches. Its wave stretches. Its time stretches. So when we look far away, we look into the past, but we also look through an ever-growing veil, one that makes the ancient light whisper, not shout, one that carries the early voice of the cosmos in a soft and rare-tinted tone. Picture this now, the cosmic microwave background, the afterglow of the Big Bang, still drifting through the universe, its waves stretched by expansion, once searing hot, now gentle, cold, faint, and yet still present, still moving through us, a memory written in light, shaped by space's quiet breathing. You are part of this history, not a visitor, but a participant in our universe that continues to unfold. Even the shape of time changes when space expands, because if the distances between galaxies grow, then the way time connects them must shift. Time becomes curved, like space. Not only does gravity bend it, expansion bends it too, and the faster the universe expands, the stranger time becomes. Some parts move away so fast that their light will never reach us, not because it's slow, but because space stretches faster than light can cross it. These regions are not just far, they are lost, beyond our cosmic horizon. And yet none of this feels chaotic. It feels like a rhythm, a slow celestial breath. Expansion is not a break in the order, it is the order. It is how the cosmos tells its story, one page longer each second, one sentence stretched across galaxies. You don't feel it in your body, you don't measure it in your day, but it is there. Beneath your feet, space grows. Over your head, time extends. And in your heart, the stillness is filled with quiet motion. You are not moving, but space is. And you, like every planet and star, drift not through space, but with it. Like notes carried on a wave, like dreams rising with the tide. And so when you breathe tonight, know that the space inside your breath is larger than it was before, that the universe around you is not fixed, but flowing, not wild, but slow, and that somewhere, billions of light years away, another galaxy fades just a little farther from view, not with a roar, but with a sigh. But if space expands and the universe stretches with time, what was the first light that filled it? And where is that light now? Still travelling through the deep, still carrying the story of when everything began. You lie still tonight, and for a moment you wonder what darkness really means. The sky above looks empty, quiet, a canvas brushed in black, but hidden within that stillness is an ancient glow, soft, stretched and ever-present. It's not the light from stars or galaxies, it's older than the sun. It's the echo of the first light, the quiet afterglow of when the universe was born. Not a metaphor, not poetry. A real light, still arriving, still touching you. Tonight you are wrapped in it. Long ago, before galaxies spun or stars were lit, the universe was dense and hot. Not dotted with light, but filled with it. Photons couldn't move freely. The cosmos was like a glowing fog, a thick soup of particles. Light was trapped, scattered endlessly by electrons and protons, unable to travel. But time passed, and with cooling came clarity. About 380,000 years after the Big Bang, something miraculous happened. The universe became transparent. Protons and electrons joined to form hydrogen atoms, and the fog lifted. For the first time, light was free. That first light began to travel in all directions, filling space, and it never stopped. It moved through time, through expansion, through the bending of space itself, and it's still traveling now. Those ancient photons, unchanged, untouched by matter for billions of years, are reaching us even as you listen. They are not bright. They do not shine like stars. Their energy has stretched, cooled, and become soft. They arrive as microwaves, a low, gentle hum filling every corner of the sky. We call it the cosmic microwave background, or CMB, a perfect echo of the universe's birth. It's everywhere. No matter where you look, above any horizon, behind any galaxy, you find the same faint glow. It doesn't come from one place, it comes from every place. It is the oldest light you can see and the most honest. It remembers a time before time had edges. And unlike the stars, it doesn't twinkle, it doesn't change, it whispers instead. This light isn't just old, it's precise. When scientists mapped it in every direction, they found something remarkable, a pattern, tiny ripples in temperature, only a few millionths of a degree difference scattered across the sky. These ripples are not noise, they are the fingerprints of what would become galaxies, clumps of matter forming in a sea of light, the earliest signs of structure suspended in the universe like seeds waiting to grow. You imagine this ancient sky now not as darkness, but as warmth. Before sound, Your eyes could see microwaves. The night above would glow with it. Not bright but full. A calm haze of light that has never stopped its journey. Every moment you've lived, every breath you've taken, this echo has passed around you, through you, like a message carried on the breeze of space-time. And yet we did not see it at first. The discovery of the CMB came quietly in 1965, by accident. Two radio engineers, Arno Penzias and Robert Wilson, were trying to eliminate a persistent hiss from their antenna, pointed it in every direction, chased every possibility, until they realized the sound was not a flaw. It was the universe itself, speaking softly in microwave tones. The Big Bang had left a trace, and it had never faded. What they found was not interference, it was original. From that discovery, a new kind of map began to emerge. Not a map of stars or galaxies, but a map of the universe's memory. Satellites like COBE, WMAP and Planck, the light did not just tell a story, it told the truth, and still it continues. The MB is not a past event, it's a current presence. It arrives every moment like sunlight from a star we can't see. It is the farthest we can look back in time. Beyond it, the universe was opaque. There is no older light to catch. It is our horizon, not of space, but of understanding. And it holds within it the clearest picture of what everything once was. You begin to feel the weight of this, that the light touching your body tonight is older than any mountain, that it has passed through silence, expansion, and time itself, just to reach this exact point. It doesn't warm your skin, it doesn't light your path, but it exists, as proof that the universe remembers, that no light once freed is ever truly lost. And what does this echo mean for you, for us? It means we are part of something continuous, not separate from the beginning, but touched by it. The same light that bathed the infant universe now floats past your fingertips. The same photons that saw the cosmos go transparent now touch the surface of your eye. You do not live beneath history, you live within it. Tonight as you lie still, this echo is all around you, passing through walls, through clouds, through space and atmosphere. It does not rush, it does not fade, it simply moves, slow and steady, like the memory of the first dawn. It carries the texture of the universe's earliest breath, and it asks no recognition, no praise, only that you know it's there. So next time you gaze into the sky and think of emptiness, remember this. The dark is not hollow, it hums, it glows with origin. The universe is not silent, it sings in microwaves, and your place in it is not after the story, but inside its unfolding. But if the universe holds the memory of light, does time remember direction too? Is there a reason we always move forward and never back? You lie quietly, breathing in the softness of the present, and a question drifts through your thoughts. Why does time move forward? Why does the future approach and the past recede like waves that never reverse? You've felt time stretch with speed. You've watched it bend around stars, but its direction, always forward, never wavers. You cannot unthink a thought, unlight a flame, undream a memory. Time flows. Always Raffaella that's more like a current than a law. You begin to wonder, is there something in nature that demands this motion? Or is the arrow of time something your mind creates? Physics, at its core, is full of symmetry. The equations that govern motion, energy and gravity don't prefer one direction over another. They work just as well running backward. A video of a planet orbiting a star looks right forward, or in reverse. The map doesn't care, but your experience does. You remember yesterday, you won't remember tomorrow. So where does this forwardness come from? The answer begins in warmth, in disorder. In entropy, you picture a hot cup of tea slowly cooling beside a window. The heat spreads, disperses, becomes part of the air. It doesn't spontaneously leap back into the cup. The process is one way. This is entropy, the measure of disorder, of how energy spreads and becomes less useful over time. And entropy always increases. It's not that things can't get organized. It's that the number of disordered ways outweighs the ordered ones. The universe, like tea cooling, moves toward equilibrium. This is the thermodynamic arrow of time, the quiet rule that guides the direction you feel, not because something forces it, but because probabilities make it almost certain. A broken egg doesn't reassemble. Smoke doesn't return to a match. These are not just habits of the world. They are expressions of entropy rising, and from that rise, a flow emerges, the flow we call time. You sit with this now, the idea that time moves forward because the universe started in an unlikely state. The Big Bang was not just a burst of heat, it was a moment of extraordinary order, a low entropy beginning. Since then, everything has been unravelling, not in the chaos, but in complexity. Stars formed, galaxies spun, life emerged. Each step brought more possibilities, each moment allowed more arrangement, and so time has moved forward, not by choice, but by unfolding. But there's something beautiful in this forwardness. It's what lets seeds grow into trees, what lets memories form, what lets stories have beginnings, middles, and ends. Without time's asymmetry, everything would be a blur of mirrored steps. But with it, there's movement, there's change, there's life. Even though the fundamental forces don't choose direction, entropy does, and that choice gives your world rhythm. You imagine now a world with no arrow, where time loops unfolds and nothing settles. It feels dreamlike, untethered, but your world is not like that. You remember waking, not falling asleep. You see cause before effect. You understand loss because you've seen it happen only one way. The asymmetry isn't a flaw, it's the shape of your awareness. Even your brain depends on it. Memory relies on traces left by the past. There are no memory traces from the future, not because the future doesn't exist, but because entropy hasn't written its story yet. And so, time feels like walking down a gentle slope, but you also can't climb back. Every breath leaves the air a little warmer, a little more dispersed. Every heartbeat flows into the next. You age, not because time forces you forward, but because the chemistry of life moves in only one direction. Cells divide, energy moves, patterns emerge and fade. It's not tragic, it's simply the texture of reality. Yet even within this one-way flow, physics leaves room for mystery. Some interpretations of quantum theory suggest time may be reversible under special circumstances. Others see time as an illusion, a shadow of relationships, but all agree on one thing. Your experience of time moving forward is not an illusion. It's a real, grounded effect of entropy rising. In a universe that began with an unlikely balance, you begin to appreciate the silence in this truth. The forwardness of time isn't a hammer, it's a whisper. It doesn't rush you, it allows you to move, to grow, to rest. Time is not a straight line, but a slope covered in moments. And each moment, from the first light to this breath, is a step in one direction. Not because you're being pulled, but because the path behind you has gently closed. And if time always moves forward, then everything you've ever done is part of that forwardness. Every kindness, every thought, every question whispered in the dark has moved with time. It cannot be undone, but it doesn't vanish. It becomes part of the order, part of the pattern. Entropy may rise, but meaning still flows through it, like music through air, like warmth through memory. You realize then that the arrow of time is not something to fear, it is a gift. Without it, nothing would change. Nothing would grow. Nothing would matter. The fact that today is not yesterday, that tomorrow is not guaranteed, makes each moment weightless and precious. The forwardness of time holds your dreams together, keeps your story moving, and gives the universe its gentle breath. So as you lie here, breathing slowly, think of time not as a thief, but as a current, one that carries you gently, always forward, not with violence or command, but with quiet inevitability. And in its wake, everything unfolds, not perfectly, not predictably, but beautifully. But if time flows differently for each of us, is now really the same for everyone? Or is now just a local truth, shaped by where we are and how we move? You lie still and wonder what now really means. The moment you call the present feels solid, shared, universal. But is it? Is your now the same as someone else's a galaxy away? Even someone walking across the room, you feel like you live in a single unfolding moment, but physics suggests otherwise. That now is not one thing stretched across space. It's something local, shaped by where you are and how you move. In everyday life, you don't notice it. You say two things happen at the same time. A car passes as a light turns green, a bell rings as a train arrives. But those are clothes, they share a frame. At larger scales, this sense of simultaneity fades. Special relativity says that different observers, moving at different speeds, will disagree on what events happen at the same time. For you, two stars might explode together. But for someone moving fast past you, those explosions are spread out. Time is not fixed. Now is not global. It's a slice, and that slice bends. You imagine yourself holding a clock. You compare it with another far away. You sync them. But the moment you move, or they do, your agreement dissolves. What is now for one becomes then for another. There's no master timeline, no universal tick. Not because the clocks fail, but because motion and gravity bend what now means for them. Think of light, always moving, always on time. A photon travels from a distant galaxy to your eye. For you, it takes billions of years, but for the photon there is no time, no passage. From its perspective, emission and arrival happen in the same instant. So what is now for the photon? The entire journey, or none of it? That disconnect shows how slippery time becomes when speed enters the picture. The faster you move, the more your now tilts forward, leaving others behind. You imagine a long train moving through the dark. Lightning strikes both ends at once, according to someone standing on the platform. But someone riding inside sees the flash at the front first. Not because the light is faster, but because motion skews time. Each observer builds a reality consistent with their frame. Each is right. Each sees their own now, and those nows do not match. That's the illusion. The comfort of a shared present that physics gently erodes. So if now is not universal, what holds experience together? The speed of light. Light defined what can be known, and when. You cannot be affected by something outside your light cone, the region that light could have reached you from. Anything beyond that cone is inaccessible. Its now is not your now. It cannot influence you, only what lies within the cone. What could have sent you a message at light speed as part of your causally connected present? Everything else exists, but not for you, not yet. You begin to feel time as a local reality, bounded by light. You're not in a global theatre where every seat sees the same scene. You're in a patchwork, a mosaic of perspectives stitched together not by clocks but by photons. Every beam of light tells you something about someone else's now. But even that information is late. The stars you see above aren't burning in your moment. They burned long ago. What you see is a sky full of pasts. Your now is made of memories arriving at different speeds. It's not just poetic. It's precise. The Andromeda galaxy is 2 million light-years away. When you look at it, you see it as it was then. A person in a different frame might say it's already collided with our galaxy. Another might say it hasn't yet formed. Relativity allows these differences. There is no fixed record of when things happen, only a relationships between events, framed by motion. Time becomes soft, directional, dependent on context. You start to let go of the idea that now is shared. Instead, you accept that your now is yours, a slice defined by your place, your pace, your gravity, your path. Someone on a mountaintop experiences time differently from you. Someone flying at high speed, even more so. The deeper the difference, the more their clock diverges. You don't feel it day to day, but the divergence grows with scale, with motion, with mass. Even consciousness joins this dance. Your brain takes time to process. There's a delay between light entering your eye and your mind forming a picture. Your now is always slightly behind. Your sense of the present is a reconstruction, smoothed by the brain to feel immediate. But it's a blend, a gentle fiction, a stitched version of reality that hides how fragmented time really is. And yet this doesn't break the world. It allows it. Relativity isn't chaos. It's order, bent gently by speed and distance. The illusion of now holds your experiences together long enough to make meaning, to share or remember. And even though no two observers agree on when something happens, they can agree on how light moves, on what's possible, on what's causal. The shared reality lies not in simultaneous moments, but in the limits set by light. You let go of simultaneity. You hold on to the connection. You realize that the world isn't broken by fractured nows. It's built from them. Every observer lives in their own slice, and yet the rules let them meet, share signals and compare notes. The universe allows overlap without total alignment. That's what makes it stable. That's what makes it work. So as you rest tonight, think of now not as a single point, but as a range, a drifting relative presence. You are here now in your own frame. Someone else is elsewhere, in theirs. And though your clocks may never match, your lights still cross, your moments still touch. And in that crossing, time speaks softly, not in seconds, but in coherence. And if nothing can send a signal faster than light, what happens if you try? Can anything truly break the limit? Or is light the ultimate barrier, the line time refuses to cross? You ask the question quietly, but it echoes through every part of physics. Why can't anything move faster than light? Why this limit? Why does the universe set a speed beyond which nothing, no ship, no thought, no signal, can ever go? You've followed time as it bends, space as it stretches, clocks as they drift. But here you reach a wall. Light doesn't just move fast, it moves at the maximum. Nothing outruns it. Nothing even catches up. And the reason isn't mechanical, it's woven into reality itself. You imagine pushing something faster and faster. A car becomes a plane becomes a rocket. Your mass increases. Your time slows. The universe pushes back, not with force, but with geometry. Motion reshapes the space around you, and in doing so, locks the speed limit in place. Light travels at 299,792 kilometers per second in vacuum. Not because it wants to, but because it must. It's not a choice. It's the result of how the universe allows waves to move through space. In Maxwell's equations, the rules that describe electric and magnetic fields, the speed of light falls out naturally. It's the result of two constants, stitched together, nothing about mass or energy, just space, just time, just structure. You think maybe if I had enough power, enough fuel, enough drive, I could break through. But speed isn't about strength, it's about the rules. As you approach light speed, your mass becomes infinite. The energy isn't a number you can reach, it's a boundary you never cross. The equations don't explode, they bend you back. And that bending is what keeps the universe stable. Because if you could move faster than light, causality would break. You could arrive before you left, send messages to the past, reverse cause and effect. That's not just confusing, it's dangerous. It erodes the structure of logic, the foundation of science. So nature doesn't allow it, not with walls, with curves, with limits that turn your forward motion into a slow drift as you near the boundary. You don't crash into it, you simply can't touch it. Some dream of shortcuts, tunnels through space, like wormholes. Others imagine quantum tricks or particles called tachyons that always move faster than light, but no evidence exists. No experiment shows a signal breaking the limit. Even entanglement, where particles seem to affect each other instantly, doesn't let information move faster than light. Correlations appear, but no usable message travels. The speed remains, untouched, unbroken. You feel this speed everywhere. It defines what can happen and when. It draws light cones around events, regions where influence is possible. If something lies outside your cone, you can't reach it, not without waiting, not without time passing. And so the speed of light becomes not just a limit, but a guide. It tells you what's real, what's reachable, what's now. Even massless particles obey it. Photons have no rest mass, so they travel at light speed by nature. But the moment you add mass, even the tiniest amount, you fall below that line. You enter a slower world, where time ticks and distance has meaning. You are bound to move slower, because mass and speed are tied together. The more you have, the harder you're held back. Imagine trying to send a signal faster than light, to warn your past self of something yet to come. If that were possible, paradoxes bloom. You could prevent your own message, undo your own choice, create loops with no origin. But the universe doesn't work that way. Every cause leads to an effect, and that effect follows behind. Light speed protects that order. It's not a wall, it's a safeguard. This protection holds across galaxies, across particles, across fields. It's the same everywhere. A rule not whispered but carved. Not enforced with punishment, but with balance. You can approach it. You can stretch your time, slow your clocks, grow your energy, but you can't cross. The moment you try, the math resists. And so you remain just below, forever chasing, never catching. This doesn't make the universe boring. It makes it consistent. If light speed could be broken, the sky would look different. Stars would shift out of place, radiation would spill forward, information would smear, but instead everything holds together. Structures form, signals arrive when they should. The night sky still makes sense, because the rules don't bend for desire, only for gravity, only for speed, but never beyond the line. Even when space itself expands, as it does between galaxies, things can move apart faster than light, but that's not motion through space, that's space growing between them. No object travels that fast. The fabric stretches, but the rule remains. Light still moves through that fabric with the same rhythm. Always on time, never late. But you begin to see this speed not as a limit, but a foundation. It's what lets time exist at all. What lets signals arrive predictably. What keeps energy bounded, shapes constant, and knowledge safe. Without it, there would be no order. No edge, just chaos. And yet light speed isn't fast by every standard. It takes over 8 minutes for light from the sun to reach you, hours for signals to travel across the solar system, years for starlight to arrive, billions of years for the most distant galaxies to whisper their light across the void. But that slowness is what gives time its meaning. If everything happened instantly, there would be no difference between now and then, between here and there. Light speed creates separation, and in that space stories unfold. So when you look at a beam of sunlight or a starlit sky, remember what it means, that you're seeing not just brightness, but boundary, a line no one crosses, a rhythm no one escapes. Every photon that reaches you obeyed that, no more, no less. You lie still, wrapped in that thought, not as a prisoner of speed, but a traveller within it. Bound by light, shaped by its pace, carried along the slope of time that never runs ahead. The universe holds to its rule not to restrict you, but to define the very speed you move through. Light speed doesn't limit your world, it builds it, but if light cannot be outrun, can it be bent? What happens when even the fastest thing is curved by gravity, pulled into new paths by the mass of stars? Light moves in a straight line, until it doesn't. You imagine it streaking endlessly through space, perfect, clean and unbent. But near something massive, the line begins to curve, not because the light changes its mind, not because it slows, but because space itself bends under the weight of gravity. A star does not reach out and grab the light, it reshapes the road. And light, always moving forward, follows that curve. This is Einstein's gravity, not a pull, but a bend. The mass of a star curves space, and light listens. You may think this sounds like theory, something delicate and untestable, but it was seen. In 1919, during a solar eclipse, the sun was briefly dark enough to let starlight through. Astronomers measured the position of stars behind it, and they were not where they should have been. Their light had curved around the sun. The stars hadn't moved. Space had. This moment marked a shift in history. Einstein's equations weren't just clever, they were real. Light itself had proven that space bends, and bending changes everything. When light curves, we see what we otherwise could not. A distant galaxy hidden behind another may still reach us, its light bent around the obstacle. We call this gravitational lensing. Not an illusion, a truth where ground mass acts like a lens, bending space and light together. Sometimes the image multiplies, one object appearing in two places. Sometimes it arcs into rings, not because the source changes, because the path does. Light doesn't know how to resist. It moves at the speed limit, yes, but it still obeys the shape of the road. You imagine looking through a telescope and seeing the same quasar twice, or 4 times. Each image arrives from a different bent path. They are not copies, they are one event split by gravity's curve. These lensing events aren't rare. They reveal dark matter, structure. the invisible web of math that light alone can't show. What we cannot touch, light helps us trace. What mass conceals, curb beams reveal. Gravity bends light, and bent light reveals gravity. And black holes, what of them? The mass is so extreme, the curve so steep that light cannot escape. Not because it slows, but because all paths bend inward. You could shine a flashlight outward, and its beam would loop back. This is the event horizon, the line beyond which even light can't leave. Around it, light may still orbit, caught in circles. From afar, we see warped light, disks of glowing gas twisted by gravity's grip, images of stars distorted by space-time's swirl. And still, light moves forward, just not straight. Even Earth bends light, not by much, but satellites must account for it. Your GPS works because we understand how light bends in gravity. The signals aren't late, they're curved, and corrections are made not by guessing, but by applying relativity. Einstein's equations are not abstract. They live in your phone, in your maps, in every satellite that sends you location and time. Each photon is shaped not just by source and target, but by the mass between. You feel the elegance in this, that something as fast, as fundamental as light is still humble enough to follow curves. It does not protest. It does not skip. It simply adapts. A beam may leave a galaxy 10 billion years ago, its path stretched, curved, altered, and still it arrives. Not lost, just delayed, just different. Each curve in the road becomes part of its story. Each bend adds depth, distance, memory, and time. Time bends too. A photon near a massive object not only shifts direction, it shifts frequency. It reshifts, stretching out. It changes tone. Light climbing out of a gravity well loses energy, not by slowing, but by stretching. Gravity doesn't just bend space, it bends time, and light bound to both carries that change. You measure it, you see it in spectra, you find stars closer to black holes send light that stretches before it reaches you. Light holds the imprint of where it's beamed, so when you lie back and look up, you are not seeing straight. You are seeing curved paths, bent images, and light that has followed warped routes. The stars are not where they seem. Their beams have shifted, their paths distorted. What appears direct is often bent. The night sky is a museum of curved light, silent records of gravity's unseen hands. What you see is a map, not of positions, but of shape-shaped mass. And still the light comes. It travels despite curves, because of them. The same beam that bends shows you the mass that bends it. The same distortion that hides reveals. Lensing lets us weigh clusters, find dark matter, and map things we cannot touch. The universe speaks in bent light. You just have to learn how to listen. This bending is not a weakness, it's a language. Every arc tells a story of a curve, every shift, a sign of mass. Einstein gave us more than a theory. He gave us a way to see the invisible, and light, faithful, fast and bending, tells the truth, not always straight, but always real. But if light bends, if time stretches, can time ever reverse? Or is its arrow fixed forever, written not in stars, but in the quiet rise of entropy? You sit with the thought, what if time didn't flow? What if it had no direction, no forward pull, no past to vanish into or future to chase? Physics doesn't demand that time move forward. Most of its laws work the same in reverse. A planet orbiting a star looks the same backwards as it does forward. A bouncing ball obeys equations that don't care which way time runs. So, where does this direction come from? The sense that time slips behind us, never ahead. You look for the answer in something softer, entropy. The tendency of things to spread out, to lose structure, to grow more disordered. Entropy always increases. A cold room warms when heat spreads, but the warmth never leaps back into the source. A broken cup never unbreaks. Smoke doesn't reassemble into a match. This isn't because it can't. It's because the number of disordered states vastly outweighs the ordered ones. The universe began in a rare low-entropy state. Since then, it's been climbing the slope of disorder, and that climb, gives time its direction. Even your memories follow entropy. You remember the past because traces of it remain. Footprints, fading heat, recorded light. You don't remember the future because it hasn't left marks. Your thoughts form in a brain that runs forward only because entropy allows it. If time were reversed, memory would erase, thoughts would unthink, and cause would follow effect. It isn't the flow that gives meaning. It's the increasing arrangement of disorder that makes forward feel real. And yet not everything follows that arrow. At quantum scales, time can blur. Particles can interact in ways that seem directionless. Some reactions happen forward and backward with equal ease, but zoom out and the arrow return. Complexity rises. Galaxies form, stars burn, ashes don't turn to flame. Life builds on this one-way street. You live inside time's current because the universe still runs downhill from that ancient low-entropy beginning. So you rest now, knowing that time may not be forced to move forward, but it does. Not by rule, but by rhythm. Not by symmetry, but by imbalance. The direction you feel is written not in clocks, but in change. In warmth that fades, in stars that cool, in your breath, moving from order to rest. The arrow is gentle, not universal, but near perfect, and it carries everything with it, even you. You've followed light to its limit, watched time bend and seen clocks slow, space stretch, and stars pull even photons into curves. You've moved with thought, past speed, past stillness, into the fabric that connects it all. But now, at the edge of this journey, you find something unexpected. Not a final velocity, not a burst of motion, but a stillness. A place beyond speed. Not slower than light, not faster, just outside of the question. Stillness here doesn't mean rest. It doesn't mean nothing moves. It means that at the most fundamental level, the deepest state of energy, the rules themselves no longer chase speed. Light moves, yes. Time flows, yes. But what happens when there's no more where to go? At absolute zero, atoms stop vibrating. Motion fades. But what happened when there's no more alberation? A flicker. A base-level hum. Just stillness that isn't empty, but full of possibility that hasn't moved yet. And in this kind of stillness, speed becomes irrelevant. The universe at large may expand, stars may race, galaxies may rotate, but beneath all that, at the quantum floor, some things don't move. Not because they're stuck, because they're already everywhere they need to be. Particles like the Higgs field don't travel, they exist across space at once. You don't detect them by chasing their path, you detect them by their influence, how they give other things mass, shape, behavior. This is stillness that holds the blueprint for motion. You begin to feel that not everything must travel to exist, that speed isn't always the goal. Some truths in physics are not found in motion, but in symmetry, in balance, in fields that stay steady while everything around them changes, and it's these steady foundations that make motion possible. Light moves fast, but the thing that defines light, the vacuum it moves through, is still. What you call empty space is not void, it's structure, and that structure is stiller than light is fast. Think of the cosmic background, not just the first light, but the quiet tone that hums behind everything. It doesn't race, it simply remains, stretching as the universe stretches, fading as space expands. It's not silence, it's the echo of everything, still arriving. This background isn't in a hurry, but it defines your place in time. You are always moving through it, and yet it never chases you. This final stillness isn't the absence of experience, it's the fabric in which all experience rests. Beyond the limits of velocity, beyond the rise of entropy, beyond the edge of space, it waits. It doesn't pull, it doesn't resist. So you breathe here, not to move, but to pause, to feel the presence of a universe that doesn't demand rush, a universe where the fastest thing, light, is still bound by something more foundational, something stillness. You are part of that stillness, not apart from motion, but embraced by what allows motion to mean anything. The calm beneath the current, the silence beneath the hum, and in this stillness, beyond speed, you finally rest, not as someone running, not as someone searching, but as part of the fabric itself, where time slows and light waits, and you are exactly where you belong.